we are going to move on down the gastrointestinal tract here. We're going to move into the lower GI tract. So this is section 3 of chapter 26. So what we're going to take a look at is going to be the intestines here, because that's really what makes up most of the lower GI tract. But we have some really important accessory organs that are going to come in and finalize digestion, because without it, then we're going to have a lot of problems. So we'll talk about the pancreas and the liver and their importance in this whole process as well. So let's first take a look at the lower GI tract organs. And again, what they do is they are going to continue digestion, because if you think about what we've digested so far, is not a whole lot. We've digested maybe a little bit of, we've digested proteins. We've digested a good amount of proteins, some carbohydrates, and not a whole lot of lipids though. That's the biggest thing right here, is we haven't digested a lot of lipids. And what happens throughout the intestines is we are going to absorb all of this. So all of the unabsorbed substance is considered a waste product. So now we need to get rid of it. So these are going to be the lower GI tract organs. Small intestine. Technically, the duodenum is actually considered an upper GI organ, but we're going to talk about it here because it's part of the small intestine. So what happens we'll talk about small intestine, about digestion and absorption, and then all the accessory organs. I say all of them, but it's 2 of them. It's it's 3. Your liver and your gallbladder and your pancreas. And then the large intestine, they are going to absorb water, electrolytes, vitamins. They're actually going to produce some vitamins as well. They don't, but the bacteria that lives in them is going to produce like vitamin K and vitamin B. This is where we're going to eliminate feces as well. So let's first take a look at the small intestine. The small intestine is quite long. It's about 20 feet long. The ileum's about 10 feet. That's the largest portion. The jejunum is going to be about 7.5, and then the duodenum's the shortest. It's going to be only about 10 inches, but it's pretty long if you think about it. The ingested nutrients spend at least 12 hours here, and this is actually really important. We want to make sure that we completely digest everything, and after we've digested it, we completely absorb everything that we need. We also absorb a large amount of electrolytes and water here. And vitamins are absorbed here as well, like vitamin B12. Remember I talked about that, and the ileum. So if we take a look at the duodenum, the main function of the duodenum is this is where the chyme is going to go into from the stomach. And it's also going to be where bile is going to go into, and also all the pancreatic juice is going to go in here as well. So a lot of things are going to go into the duodenum. So this is a lot like a receiving chamber. After that, it goes into the jejunum. And this is going to be where the primary location of digestion, where we're going to finish digestion, and pretty much all absorption is going to happen here. I don't want to say all of it, about 90% of absorption is going to happen here. And then the very last portion is the ileum. Don't get this confused with the bone. So it's spelled differently. So make sure that you know that. But the ileum is going to be that very last portion, the longest portion. But it's funny because there's not a whole lot happening here. We do have a little bit of nutrient absorption happening. We do have some vitamin B12 that's absorption happening here as well. But it's interesting how it's the longest part, but it's one of the, I'm so sorry. But a lot of the other action happens earlier before that. And there is that ileocecal valve. This is a beautiful picture of the ileocecal valve or junction right here. There's the ileum. It's going to empty into the cecum right here. So we'll look more at that valve later on. That's going to be our next little sphincter that's controlling. It's a valve, but they're going to do the same thing. But it's going in and controlling that movement that's going from the ileum into the cecum, or the small to the large intestine. Let's take a look at the really important gross anatomy of the small intestine. And usually I don't get too technical into gross anatomy, but this is really, really important. The first thing that we're going to be taking a look at, these circular folds. These are also, I've always called them plica or plica circularis. Plica. I think the book tells you to say plica, but I've never I've never seen that before. But there's plica, and then there's the circularis. Yes. Plica circularis. So what these are going to be these folds that you can see in here. These are permanent folds, unlike the rugae that's found in the stomach. So these are always here. And they are going to be folds of the mucosa and also the submucosal tunics. What they do is they are going to help increase surface area. So remember, the reason why we have this kind of, anytime we have something like this, it's always about surface area. And remember, the importance of surface areas. The more surface area we have, then the more work that organ can do. And if this organ specializes in digestion and absorption, then we are going to be able to get as much nutrients absorbed as possible because of all of the surface area we have here. They also kind of act like speed bumps. As the chyme hits it, it causes it to slow down, because we don't want chyme to rush through. We want it to take its time going through so we can absorb everything as much as possible. We'll talk about diarrhea later on and how this is where it moves very quickly through and you don't get any nutrients absorbed because of it. We'll talk about that one later. So these circular folds are going to be the most numerous, where we're going to have digestion and absorption happening. So that is going to be in the duodenum and the jejunum. And by the way, if you say duodenum, that is completely fine. So there's a lot of times in science you will find that there are a couple of ways to say these words, and that is completely fine. All right, so let's take a look and see what's happening on those circular folds. So this is one single plica right here. As you can see, there's one of the little plicas. But as you can see, there's like tiny mini plicas that are on top of the plica right here. These are villi. A villus is one. Villus is the singular form. So this would be one single villus. This would be one single villus. So these are going to be these little finger-like projections that are coming off of the mucosa. You are going to have these most in the jejunum. And again, surface area. If we want to have the maximum amount of absorption, and remember, most absorption is going to come in the jejunum. That is going to be where we have most of the of these villi are going to be in here. You have some in the duodenum, but not as much as in the jejunum. And when you get to the ileum, specifically the distal part, these are pretty much all already gone. And also, if you take a look and see what's in there, you have little arterioles. You can kind of see in there capillary networks, and then the venules as well. And then if we look at the, so if I drew the plica, and then I drew the villi like this on it, I kept on going, then what's going to be on top of the villi are going to be these tiny little projections right here. And that's what this picture is right here, is showing, is those little tiny little things I just drew right there. It looks like a brush, doesn't it? Just like a brush. And that's why this is called the brush border. These are microvilli, and because it gives a kind of fuzzy appearance under the microscope, it's called the brush border. Some people say it looks kind of like a toothbrush. I don't know about that, but a little bit, I guess. Remember, if you remember in 2401, and you talked about the difference between like cilia and microvilli, microvilli is going to be there for surface area, even more surface area. So we have so much surface area action happening here that there's just no way that we're not going to be able to absorb as much as possible. What happens here is that you also have these little things called brush border enzymes. Brush border enzymes we'll actually talk about later on in absorption. These are going to be specifically targeting like very specific disaccharides and very specific oligopeptides, breaking them up into the most simple form that we can absorb. So these are essential, and we'll talk about brush border enzymes and how if we don't have one, then the problem that's going to cause. Because one of these brush border enzymes you might have heard of, lactase. And so we'll talk about what happens with lactose intolerance when you don't have those. They also are going to have these little proteins that are going to help transport any digested products as well. But there is the importance of your microvilli there. Another thing, of course, don't forget about that lacteal. That lacteal is going to be found in the intestinal Villi, as you can see, it's right there in the villi, and these are important for absorbing lipids. So that's why we have these, and also lipid-soluble vitamins. So now let's take a look at those little cells that are found here in the small intestine. So this is a nice little picture. It's just like the one we saw in the stomach. So as you can see, here's that simple columnar epithelium, microvilli. These tend to have a nice regenerative property as well pretty quickly. Really, if it's so much so, and also of the stomach, that a fourth of our feces is actually dead epithelial cells that we've shed off. And it's kind of creepy if you think about it, isn't it? But there's your simple columnar epithelium. So we're continuing with that simple columnar, but now we're going to have microvilli on it. And again, absorption of nutrients. So what we're going to have here is going to be these goblet cells. Goblet cells are going to secrete mucus, which is going to be really important. Specifically, we'll talk about some special ones here in a second in the duodenum and how really important that is. But as these goblet cells right here, these specific goblet cells right here, these are actually going to increase. We're going to have more in the ileum. So we'll have some in the duodenum, and then we'll have a little bit more in the jejunum, but even more in the ileum. And what's happening is that the mixture in the intestines is changing from stuff that we're trying to absorb, this chyme, and trying to absorb all of these nutrients, and by the time we get to the ileum, we've absorbed most of it. And we need to start moving it through and lubricating it down. You also have these unicellular glands, and these are going to make some enzymes, synthesize these enteropeptidases. We will talk about those later. You have more of these enteroendocrine cells. Those are going to release CCK and this GIP hormone. We've already talked about CCK, but we'll talk about a little bit, or actually a lot more here later on. Other ones that you have that aren't shown on here because they are mostly found in the duodenum, actually they're solely found in the duodenum, are these duodenal glands or submucosal glands. I like to call them duodenal glands because it tells you exactly where they are. These secrete an alkaline mucus, and if you think about it, why it's important, because it's taking in that really acidic chyme. So the duodenum needs a layer of protective mucus so it does not get destroyed by that acidic chyme that is coming into the duodenum. So let's take a look at motility of the small intestine. So there's going to be three main primary functions for the smooth muscle movement. One of them is to mix the chyme with all of the gastric glands here, or sorry, not gastric glands. We are not in the stomach anymore. And apparently it's late because I am yawning a lot and I just said gastric glands here. But anyway, it's going to mix it with all of the glandular secretions that we're going to have. Remember, we haven't talked about these yet. Bile and the pancreatic juice. Also, we have a special movement that's going to happen here, this mixing movement called segmentation. I introduced this way back at the beginning of the chapter. That's that kind of mixing motion, that back and forth movement. It's going to go in and break it apart like this. And make sure that it's mixing it all with the glandular secretions, increasing that surface area so we can absorb as much as possible. Another kind of movement, motility in the small intestine is going to be when it moves the chyme up against, kind of back and forth against new areas of the brush border as well. So we talked about that importance of the brush border. And then last but not least is, of course, peristalsis. Peristalsis is going to begin in the esophagus, and it continues all the way through, again, of course, until we get to the very, very end of the large intestine. So because this is what's moving that food down through the GI tract, is going to be peristalsis here. So we have this gastroileal reflex. And what this does is it is going to, as the contents move from the ileum to the cecum, you typically have the ileocecal valve that is going to be constricted, but in order to move it from the ileum to the cecum, it needs to be open, and that is going to be that reflex that's going to go in and control it there. So it moves the contents from the ileum to the cecum in response to the food in the stomach.